Hello, welcome to Getting Started, Part 2 of Shed Math. This lesson continues where Part 1 ends. The concepts and skills you will master in order are how to calculate the long leg of a right triangle by using the Pythagorean theorem. And the long leg of a right triangle is called the hypotenuse. In order to use the Pythagorean theorem, we're going to be discussing three things in order: exponents, roots, and the Pythagorean theorem. But before we start, I want to talk about measurement and some very practical things. When at all possible, always try to work with one unit, either all meters, all feet, all inches. It's also easier when dealing with the calculator, deal with decimals rather than fractions. If working complex calculations, working with the calculator, do not round off, do not convert to a fraction to the very end. And then if at the very end you need to convert it to a fraction, then do so. In this exercise, I'm going to be asking you for your measurements as a fraction to the nearest 16th of an inch. Also, all of my calculations are going to be in inches because I want to keep my calculations relatively simple and I do not want to convert them. Understand that every time you express a number or convert a decimal to a fraction, your answer becomes less precise. You are introducing error. So, as a practical rule, stay in the same unit, do all your calculations, and then at the very end, do any conversion if necessary. There's a lot of mathematics involved in constructing a scale model of something, and therefore there are a lot of math concepts in this course. Think of math in this course like a tool in your toolbox, a skill to be mastered and used in building your shed. Your objective is to be able to build your shed. Math is simply a tool you need to use to do it. When you work on a calculator, you work with decimals. You read fractions of an inch on your tape measure. So how do you convert a fraction into a decimal and a decimal into a fraction? A fraction is just another way of writing a division problem. 1/2 can be read as 1 divided by 2. Use the calculator. Press 1, press the division key, press 2, press the equals button. Your answer is 0.5. The decimal equivalent, which basically means that it has the same value of, to 1/2 is 0.5. So anytime you need to convert a fraction to a decimal, it's just the top number, hit the divide key, bottom number, equal sign. It will come up with a decimal, and that is the decimal equivalent or the decimal value of that fraction. It's relatively simple to convert a fraction to a decimal by using your calculator. However, converting a fraction to decimal is a little bit more complex. Because in this course, I'm asking you to identify fractions to the nearest 16th of an inch. And because it's a little more complex to convert decimals to an exact fraction, for the purpose of this course, I'm going to go ahead and ask you to use this decimal equivalent conversion table. If you look to the right here, we have numbers. If I take the number 3, hit the divide key, 16, press the equal button, I come up with 0.1875. This is the same numerical value as this. This is just in fractional form. This is in decimal form. So you find the decimal you have, you find out which one of these it's closest to, and then you choose the appropriate fraction to the left. So in this particular example, I'm looking at the value of 0.335. I come over here, well, there's 0.31, there's 0.37. I say which one's closest. Well, 0.335 is closest to this number right here. So the fractional equivalent would be 5/16 is the closest 16th of an inch to 0.335. Find your decimal, find out which one's closest to it, look immediately to the left. There you have your fractional equivalent. Now we're going to be talking about the Pythagorean theorem. You will be able to calculate the length of the long leg or the hypotenuse of a right triangle using the Pythagorean theorem. In my opinion, it is one of the most powerful math tools I have ever seen. Very practical and very easy to use. When I left high school, this is one of the very few math equations that I actually had memorized because it was so practical, and I used it all the time, especially when I was helping my parents build their house. Now, before you can use the Pythagorean theorem, you need to know two specific skills. You need to understand what exponents are and roots are. So in order to proceed, before you do this, please pause this presentation, open the course directory and select the file titled Exponents, Roots, and the Pythagorean Theorem, and then watch all three videos in order. I'm going to go ahead and pause for 5 seconds and then continue on. Now let's calculate the length of the missing leg of a triangle. I want you to pause the video. I want you to work the problem. And then when you think you have a solution, move on to the next slide and we will talk through the solution process. Here's that theorem that he talked about. A squared plus b squared equals c squared. It doesn't really matter which one of these are A, which one is B, except for in the Pythagorean theorem, the long leg or the hypotenuse will always be C. So I'm just going to say let A be 3, B equal 4, then I'm going to substitute them into the equation and solve for C, because that is what I'm trying to solve for. I want to know what the value of C is. Well, there's A squared, so I plug it in here, it becomes 3 squared. B is 4, becomes 4 squared, C squared. I do the math, 9 plus 16 gives me 25. So now I can say that C squared equals 25. So now I'm going to take the square root. I'm going to find the root of both 25 and C squared. Square root of 25 is 5. Square root of C squared is just C. So C equals 5. The length of the hypotenuse here is 5. Now, a couple more things. These concepts I'm going to cover were briefly covered in the video series, but I want to elaborate a little bit more on them. If I asked you what the value of 15 plus 10 minus 15 was, how would you solve the expression? You could do the long action of adding 15 plus 10 and then subtracting 15 to find the value 10. In other words, 15 plus 10 is 25, minus 15 is 10. Or you could recognize that when you add and subtract the same value, they cancel each other out. There's 15 and I'm subtracting 15. So in the problem above, 15 minus 15 cancels each other out because subtraction is the opposite operation to addition. It has the opposite effect. It undoes it. So adding 15 and then subtracting 15. So cancels each other out and your answer is 10. Now let's move on and talk about if I'm using algebra or variables. Now remember, a variable is simply a placeholder. We don't know what the value is. So we're assigning the letter saying we don't know what it is, but we're going to use this as a placeholder till we figure it out. If I write the expression a plus b minus a, what is the solution? A minus a cancels each other out, leaving only b. Likewise, if I write a squared plus b squared minus a squared minus a squared cancels each other out, leaving only b squared. And one last thing, I want to talk about solving equations, balancing an equation. Think of the equal sign as a balance. In order for the equal sign to stay true, whatever you do on one side of the equation, you have to do on the other for the equation to remain balanced. In other words, whatever operation I do on the left side of the equal sign, I have to do on the right side of the equal sign in order for this equal sign to remain true. Now, in the context of Pythagorean theorem, if I say I want to find the value of b squared, I go through the process of isolating b and using the inverse operations. Now, when I say isolating b, what I'm saying is I'm trying to get everything on this side, with the exception of what I'm trying to find here, from the left side to the right side, so that I'm left with some kind of equation, say b squared equals something. So to get rid of this a squared from this side of the equation, I'm going to do the inverse operation. I'm going to go a squared plus b squared minus a squared. A squared minus a squared cancels each other out. But in order for this equal sign here to stay true, for the equation to remain balanced, since I subtracted a squared from this side, I have to subtract a squared from this side. Whatever I do on this side, I have to do exactly the same thing on this side. So I subtract a squared from this side, and it gives me the answer of b squared, it's now by itself, c squared minus a squared. And I went through that because you're going to have to use this technique in order to solve for b. I want you to pause the video, work the problem, and go to the next page to see the solution process. Same theorem. We have a right triangle, hypotenuse, one leg, two legs. I want to find the value of b. So the first thing I'm going to do is I'm going to isolate b squared. That means I'm going to get everything off the left side except for the b and move it to the right side. So what I'm going to do is I'm going to write the equation a squared plus b squared minus a squared equals c squared minus a squared, because I'm trying to get rid of the a squared, so all I'm left with is a b squared on this side of the equation. And since I'm subtracting a squared from this left side, in order for that equal sign to be true, I have to subtract the same thing. Now, just to make things simpler, I'm going to go ahead and substitute in the known values into the equation. I know that 3 squared plus b squared minus 3 squared equals 6 squared minus 3 squared. And we know that that cancels that out, right? So on this side of the equations, all I have left is the b squared. 6 times 6 is 36. I know that 3 times 3 is 9. Do the math. B squared equals 27. Now, I'm going to find the square roots of both b squared and 27 in order to find the value of b. Square root of b squared is just b. The square root of 27 using my calculator is 5.196. And just a little side note here. When you're finding these roots, you'll frequently find long decimals, so fill up your entire calculator. For the purpose of this course, and for the purpose of these calculations, you can stop at 3 decimals. So in this particular case, I did 5.196. Now when I actually use the calculator, it comes out with 5.196152423. But I'm not going to carry out all those decimals. I'm going to stop at the 3rd decimal place, which is thousandths. So 5.196, and I'm going to stop there. Now, I have that value here. I'm asking you, when you find your solutions, to convert them to a fraction. So I'm going to use the conversion table that we did earlier. And I know that the value of 0.196, 3/16, is the nearest fractional whole. So I have 5, there's my whole number, and 3/16, which represents the answer to the nearest 16th of an inch. Your assessment regarding using the Pythagorean theorem will be in the next lesson, Getting Started Part 3. You will use it to figure out the length of your rafters in the shed you will be building. This is the end of Getting Started Part 2. In this lesson, we discussed the Pythagorean theorem, including exponents and roots, and how to convert fractions to decimals, and how to convert a decimal to the nearest 16th of an inch using a conversion chart. In Getting Started Part 3, you will calculate the scale length of your rafter, calculate the scale length of all your parts, cut all your framing parts for your model. This concludes Getting Started Part 2. See you in Part 3.